哦，OK OK，
係啊係啊
OK
OK OK。
There's a charge over there if you want to charge。喺度有一個。係啊係啊。Hi. Testing, testing. Happy New Year. I think we haven't seen for 2 weeks, but I guess you guys may have seen each other in another occasion. I noticed some of the class still going on in the Christmas and New Year time. But at least I hope you have a good break. Is it the mic is okay or no? Okay, good. The mic is good, right? So so what is the goal today? We are slightly behind the schedule, but some of you told me that it's better to make sure that everyone understand rather than I rush through. So I would keep it this way. And I also received email that I shouldn't do any touch on the slides since I'm a printer. So I'm not going, the slide I'm not going to touch. If there's typo, I would just point out there, okay? And so this is a slide, and if you print out, then don't worry, I'm not going to change anything. And for sure that I have more material that I put on the slide than I cover. So for those material that's not, I taught in the class, so you don't have to worry. You can just cross out, as you said, some of you said, just cross out the thing that I then taught, okay? The goal of today, I mean, before the dinner, right, is, I guess some of you just have lunch, right? But anyway, just before the dinner is talk about the uncertainty in the temporal choice. And for uncertainty, actually, we covered a little bit last time, so but we'll finish it. And let me very briefly review what we have discussed. So let me take this full screen, and then we will do the, we'll start, okay? Why this guy's do that? Yeah, good. So the first part is uncertainty. We cover half of that, and the second part intertemporal choice, okay? So these topics are, I guess, it's the most important part in the finance, right? Because finance is trading about, in general, right? It's talking about future claims, right? Future payoff, or the stock is a future payoff dividend or the capital gain, right? Or bond is also the same thing, a similar style. It's about in the future, it's in the temporal. And uncertainty is also very important, right? And only very few things in the world is risk-free, right? Only the, possibly people would call, only the government bond is risk-free, or the gold, right? The bricks are risk-free. Otherwise, it will be, everything is risky. So uncertainty is important. So let me we'll quickly review what we have done last time. So we talk about how people make decisions under uncertainty, right? The classical model we talk about is under certainty, then everything is very nice. We know what's going on, everyone knows what's going on, then things are very, very simple. But the problem with uncertainty is, the first problem is how to model it, right? How do you model something we don't know, okay? And the way we proceed is very classical, okay? I said classical means that many new ways to model it, but we focus on the one that is commonly used and still commonly used in finance, okay? That's why we use it, and economics as well. So the way we do is a classical idea following the idea of probability, okay? We model the future of unknown future. As a future, we know which outcome are likely, but we don't know which one comes out. And we have assessment of probability, the objective probability. Okay, it's a very classical idea. And under this classical framework, the way we model investor or individual is what we call expected utility, which we will review again. And after that, we talk about intertemporal choice. But that's what we covered last time, right? We talk about how we model uncertainty is just imagine a case where you go to casino, that's the easiest thing, right? The casino, the simplest thing or the gambling is toss a coin, right? Either you head or tail, okay? If the coin is fair, then you have head half of time, tail half of time, right? So it's always either head or tail. You don't have surprise. It's not a magic show where you toss a coin, a rabbit comes out. No, right? You know which might be come out, okay? The only surprise is why this come out, but it's not this thing comes out, okay? And this is a classical way to do it, okay? Then that's the way we learn probability. If you recall how you learn the first time you learn probability, that's what you learn, right? We have a sample space where is all possible outcome there. You have number from 0 to 1 assigned to each outcome, right? Probability, or the number add to 1, right? That's how we do that, right? The simplest way to represent this is by tree diagram, right? We talk about lottery, right? Just toss a coin, right? If under some situation, the outcome is x1. Under this x2, the two outcome there. Outcome 1 has probability p. Outcome 2 is 1 minus p, add up to 1, right? Of course, the more higher the p, then it's more likely that the outcome 1 comes out, right? So that's very general the way. Of course, you can easily see that this tree can expand to as many outcomes as we want, right? So you just put different probability there, right? Just like tossing a coin, so rolling a die, you have 6 outcomes. If the die is fair, each outcome is 1/6, right? So that is the standard way we do. And to look at the lottery, one of the important things you learn from probability theory in undergrad is what we call expected value, right? Is how you look at the lottery, you will be thinking about what's expected value. The meaning is if you repeat this many times, right? So suppose this lottery, here it means that half of time you get $3, half of time you lose $1, right? So what is expected value is a very important metric, right? Because suppose you keep playing this lottery many times, right? Suppose you play 1 million times, okay? And you expect half a million times is 3, half a million times is -1, right? All this number, you can calculate average, right? Half a million 3, half a million -1, add together, over 1 million of them is exactly 1, right? So this is the value you pay, right? So suppose you keep paying this a lot of time, so it means that on average, each round you win $1, right? So usually we expect if we take this bet, if we are allowed to take it, right? If we are, maybe you don't want to take it for 1 round, right? But if I allow you to say you take 1 million of this, you would take it, right? Take 1 may be very risky, right? But you take a lot, right? Then what you will get is like this, right? That's what we call, you learn in the undergrad, is what we call the law of large number, right? If you take many times, right? What you actually get will be no different from this one, right? And that's the reason why the insurance company can work, right? Because insurance company insure everyone, right? For individual, it's uncertain, but for the insurance company, they know exactly what's going on. They can do calculation, right? But anyway, that is a side story. But this very important metrics to evaluate uncertainty. But turn out that this is good for gambling, right? Whether you want to gamble can be based on this expected value. But turn out that people is not based on this one, okay? Expected value is not a good metric. This is a good metric if you are, later we will call risk neutral, okay? If for a big company, you can just focus on expected value, okay? But for individual, you will not, okay? That is happening how we model investor behavior, right? Small investor will not do this, but big investor, they can do this. Okay. Later you will see in more detail, but this is very important metrics. Okay. Now, in the literature, usually you will see fair and unfair. Okay. Fair is very simple. Fair means the expected value is 0. Okay. Which means that in the long run, you play this lottery many times, you don't lose or gain. Okay. And unfair means it's not 0. And in general, the casino is very close to fair. Okay. Usually the rate is like if you pay $100, you would win back $99 or 99.3, something like. You lose several cents per $100 bet. Okay. That is what the odd ratio, like the lottery machine, right? The slot machine. Okay. Suppose you put $100 in. You will get $99 on average. Good. On average, you lost $1 per round for $100. But that means it's not fair, right? And most of the things are unfair you see in the world, like Mark 6 is unfair because probably many of you know Mark 6 is like the government take $20 for every $1, the government take 20 cents. And the horse racing association also take some percentage, and the rest will be shared by everyone, right? So it's unfair, right? Because someone take away something, right? Or in the mahjong shop, right? I mean, even you pay around people, then the shop will take away some money. So it's unfair. Okay? And if you're happy to take fair lottery, we will call risk neutral, which we'll define later, okay? And that's very important. That's why we have to emphasize this one. So here give you how individuals think about lottery. That's a preference, right? Remember how we start the class? We start with preference. Preference creates demand, right? But in terms of finance, right, we talk about uncertainty of the future cash flow, right? So we need to talk about lottery anyway, right? You can imagine, right? This is like a lottery. It's a company. In the good times, he'll get $3 give you. In the bad time, he'll give $1, right? And consider other stock, right? Which is a small stock, right? And a startup, most of the time he would have nothing but go bankrupt, right? And for a amount of time, he will get $20. Okay? And you look at this, okay? And you will ask yourself, which one you prefer, okay? And some of you, okay, let's ask this question. If you are the investment manager, which one do you take? So suppose you are handling the M.P.F., okay? Say, for example. Who take this one? Okay, you? Who take this one? Only one, okay? So you guys are very good, okay? In general, but if I take this one. Why? Because M.P.F. is not my money, right? I think the first thing that I learned finance is the professor taught me was finance, right? He tell me finance is other people's money. Okay? You just invest and then just not your money, right? So then you invest this, you earn $20, then you get a high bonus, right? And then it doesn't work, then you just go to find another job, right? But anyway, whether you take this one depends on the risk, right? Joke aside, right? Depends on the risk preference, right? Look at this one. The expected value of this is $2, right? On each round, you all get $2, right? Either you get 3 or 1, on average $2, right? And this one, on average, you also get $2, right? So this you can't really tell even if you're risk averse, actually either of them would work, right? But if you take this one, right, probably you don't want to take risk, right? And this thing is depend on individual, right? How likely you take risk. So we will have some people may prefer this over this, some people may prefer this over that, or indifferent. Okay, so there's a preference there. So we start with preference, okay? So now assume, we don't assume which one will be prefer, but we will try to measure it, okay? But this is, we can tell people we prefer this over this or the other way around. The same as what we see in the first chapter, right? People may prefer apple over orange, or some people prefer orange over apple. We can't tell. This is basic of the model. We don't explain it. Psychology will tell us which one would take. Okay? New psychology actually look at the neuron, will tell you which one to take, right? Can depend on your genes, right? Your ancestor, how likely to take risk, right? Some genes make people take more risk. Some people take less risk, so it depends. But we don't explain that. This is a psychology or problem. So we just take it as given. You tell me which one you prefer, okay? And we will, same as the chapter 1, we assume the preference have some nice property, okay? Some nice property complete means that you give me 2 lottery, okay? You can tell me which one you like better or the same. Fair? Second one is like a consistency property, okay? If you like A over B and B over C, okay? And then I give you A and C, you will take A, okay? That is consistent, right? So I think that is usually not a problem. So that is, we have in the chapter 1 already. So nothing new there, okay? Usually that's called rational, right? If this is not true, that's not rational, okay? And the third one we assume is what we call continuous, okay? As I mentioned in the topic 1, right? What is not continuous? It's when you have less geographic preference, like the Shanghai marriage market, right? If you always demand, you have a house, have a car, have a kuko, so on and so forth, one by one by one by one, it's not continuous, okay? And in general, finance is usually continuous, doesn't matter because you deal with money, okay? So what it means by continuous means that, suppose you tell me that you prefer X over Y, okay? Remember, X and Y is the first example we have, okay? Okay, you say X, when Y you like X better, slightly better, okay? Much better than Y, okay? And then I make some changes to the numbers, okay? 3.299, 1 become 1.01, and 20 become this, just change the number, okay? And this, you still prefer X over Y. Is that clear? So your preference of lottery doesn't change suddenly if some number changes. Fair enough, I guess. Usually it's not a problem if you talk about investment. It can be a problem when you go to economics, but in finance, usually not an issue. So I don't want to emphasize too much, but just give you the foundation of how we start there. And the third one is called independence. Independence is slightly a little bit complicated, okay? It means that I give you tell me X over Y, okay? Say suppose you tell me you prefer this over this, okay? So now I give you other thing, okay? Maybe half of the time you get X, okay? Half of the time you get something God said is something like maybe toss a coin, or I'll give you a lottery ticket. Say suppose I give you a Mark 6 ticket, which represented by Z, okay? Or half the time you get Y, and half the time you get lottery ticket. getting more complicated, right? You say x and y. You say x over y. Now I said, no, let's don't pay this, okay? Half the time you get x, half the time you get a Mark 6 ticket. And half the time you get y, or half the time you get Mark 6 ticket. You still remain the same, okay? Getting a little more complicated, you just take away this thing, the same thing here. It's called independence. Okay? And actually, what does that mean here is, it simply means very simple in finance, right? Suppose you prefer stock X over stock Y, okay? Now consider in the world where things got crazy, right? Suppose there's a pandemic comes, okay? Touch wood, anyway, and pandemic comes out, everyone got nothing. Very bad case said, right? So you see the same, doesn't change, right? Or in the case you're considering, say, evergreen bonds, okay? You have, maybe they have a, the first class bonds or subordinate bond, say, right? But when you default, you get nothing anyway, right? So your preference will be the same. Just you can much simplify stuff. You do not need to consider things that is unrelated, right? So suppose you like this bond and this bond in the portfolio, you don't really worry about it. So you basically you can isolate your investment decision, looking at only compare two different things. You don't need to compare holistic, right? Otherwise, you have to think in the whole portfolio, that's very complicated. Okay, so that is make our analysis very simple, right? That's why we can focus on analysis of each single financial investment, right? We don't have to say this portfolio versus that portfolio. No, we look at whether we have looked at very fine case whether we invest in this stock or this stock, which one's better. Okay, so that is very important. Okay, and the next one is what we call compound lottery, and compound lottery simply means that you have two lottery. Okay, maybe you have two stocks, right, X and Y. Okay, and compound lottery will be saying that with some probability you go to this lottery, for some probability go to this lottery. Okay, it's a little bit complicated. You can think in this way. Draw a tree diagram, right? So with product Q, you go to the upper lottery. With 1 minus Q, you go to lower lottery. Okay, and that in our basic model, okay, what we want is, this is very complicated in our head, right? You can imagine that, say, in the economy is good, this stock will give us this return, and economy is bad, the stock will give this return, right? This standard thing you would imagine, right? This scenario analysis, many of you would know how to do it, right? And how can we do this analysis, right? And the way actually many of you have done is you just combine, look at the outcome directly, right? You don't care about how you get to the outcome, right? You just care how much money you get, right? In that case, you can collapse into this simple one, right? Because when you have this upper round and this third round, okay, give you x1. So just add up the probability there, right? This time this and this time this give you this one, right? And x2 we just this time this, right? And x3 this one, okay? So what we're assuming is we don't care how we get our number as long as we don't care the number, right? So that's the thing, right? You don't need to worry about how the complication arise. Just care about how much money we get at the end. Is that clear? So it's a simplification. We don't care about what kind of scenario you're making, okay? As long as the money is the same, that's the same. Okay? Of course, it looks trivial, but a lot of time, how to frame the thing is very important, right? Many of you are practice economists or financial practitioner, right? How you package a product is very important, right? How you think about the future is very important. But here we say the guy is very super smart, okay? He will not be illusioned by how the thing is being presented. He just think directly, final number there. Only number matter at the end. Okay, it's very smart, right? But at the end of the day, I mean, a lot of us actually not that smart anyway, in most of the time. So that is what we have. Why we talk about so many things here? Because of all the axiom we have, okay? We know how people behave under uncertainty. And it's a very simple model. And this is coming from Neumann Morgenstern. Those who know Neumann, right, probably is the one of genius in the World War II, right? And then he proved that this is the case. Okay? What this is, what we call the expected utility. Okay? So let's see what it means. Okay? Let's look at the example, will be easiest. Okay? So consider a lottery. Okay? In one scenario, probably P get X dollar, 1 minus P got Y dollar. Okay? This is the first scenario, so stock L. Okay? And look at stock L prime. Okay? With P prime, probability you get X prime. With 1 minus P prime, you got Y prime. Okay? And how you would think about how the decision maker is going to make decision. Suppose they are smart according to the axiom we have said. Okay? It's very simple. Okay? He would evaluate stock L by doing the following. Just probability times how much he like the outcome X. Okay? Outcome X here is a certain outcome. How much he like $10, say. Okay? And 1 minus P, how much he like Y dollar. Okay? And how he likes L prime is just the same concept. Okay? It's just probability times his utility getting X prime and Y prime. So there's no uncertainty involved, right? Except by weighting the probability, how likely it comes. Okay? So that is called expected utility. It's because of look at the utility at different outcome, calculate expected value. Okay? And we assume that people would behave according to this. It's called expected utility maximizer. And that is what used in 95% of the current finance literature. 90%, maybe 95%. Okay? If you before 2000, basically everyone used this one. Okay? So what, and that will give us the foundation of how we do things. Okay? And that's very important because we just need to know how much you like this outcome and how much this outcome, right? And the probability just change the weighting. That our life is very easy. Okay. Now, we are going to use several definitions, which is pretty standard. Okay, and that's how we proceed. Okay, and the first thing is look at what the U, right? Well, I tell you that we can describe human individual behavior based on the U, right? Because remember, look at the expected utility theory. Okay, everyone look at this lottery. Everyone look at the lottery is looking at each outcome definitely weighted by probability only, right? So the difference between you and me or the other classmate is just a small U function, right? And if your U function is the easiest case risk neutral, okay? If your U function, okay, look at the utility of lottery, it's same as your utility getting the expected value of lottery. Okay? You just care about the expected value, that's called risk neutral. Okay? If your utility of the lottery is less than give you the expected value, you call risk averse. Otherwise, it's risk loving. Right? So, and in general, okay, as a finance, we will look at all the case, all the people are risk averse. Okay, reason why? Ask ourselves, is bond pay more or stock pay more? Right? In general, stock pay more. Why? The standard answer is stock take more risk. Right? So you need to compensate people for taking the equity position. Right? So that's most people risk averse. Right? But of course, some of you ask, okay, if you're right, then why people buy lottery? Right? Lottery is risk loving, right? Right? Because in general, the expected value is negative, right? But you still want to do that, okay? And I would say in finance, in the most case, in the market, basically risk averse, okay? And insurance, you need to pay for it, right? Rather than the other way around. So that's why it's risk averse, okay? And we'll go a little bit more, but these are the three concepts: risk neutral, risk averse, and risk loving. Okay? And here we give you a more mathematical or graphical thing. If you are risk neutral, it's very simple. It's simply you have more money, your utility just go up linearly. Why? That's argument. Now I give you $2 for sure, or half of time you get one, half of time you get free, right? Risk neutral means that they're same to you, right? So I give you half of time one, half of time free, half of it will be just here, right? Which is same as I give you two directly. So that is what we call risk neutral. It's always a line. Let me repeat, because probably you don't get straight away. So remember how you look at the things if you are expected utility guy. So half of time you get one, half the time you get free. Okay? What will be your utility? If I give lottery, half of time is one, half time is free. So look at this number, you have one, you have free. Average of this is the middle point. Okay? And it's here. And if you're risk neutral, that means that you don't really care, right? This will be exactly the same as half of here. So that means this is linear. Okay? It is linear. Okay? And it means that linear means very simple idea, right? It means that if you have $1, I give you $1 more. Okay? The happiness you get is same as you go from 2 to 3, and 3 to 4, 4 to 5, 5 to 6. Right? So, and that means that what? If you're rich enough or a big company, that is what your behavior. Right? Suppose you are managing a billion fund, right? Whether you get $1 more, $1 less doesn't really matter. Right? You have a lot of money, a small bet, very small bet, you will be risk neutral. Right? As long as it doesn't affect a lot of things, right? So you're willing to take as long as you don't really care. Right? So that's why risk neutral is the best when you have a lot of money, or at least the bet is small compared to your wealth. That's a good approximation. Right? So if you are, for example, you try to model a big investment fund, you're making a small bet, then risk neutral is the way to go to evaluate, right? That's very simple. And if you're risk averse, the way you look at it is like this is a concave shape. Why concave shape here? Okay. Look at this diagram here. Okay. You get one, you get this payoff, U of 1. You get 3 here, you get U of 3, right? We talk about half of time you get 1, half you get 2. So half of 1, 2 is just middle ground here, right? So this is utility. If I give lottery, if you 1 and half of time. But this is lower than I give you 2 directly, right? You rather want to get $2 instead of paying a gambling of 1 or 3. Okay? Then this is risk averse. Okay? And in general, you will see the second derivative is less than 0, but if you don't know calculus, it doesn't really matter. But just remember the concave shape. If you want to math, that's an idea. Okay? Okay. Is that okay? And you can see if you're risk-loving, you'll be convex. But as I said, we don't need to worry about this in the financial market because usually it's not that matter, okay? Unless you talk about something like lottery ticket like stock, okay? IPO, or somewhere stock have a huge growth potential, like the GME, right? Or those kind of things. Otherwise, in general, we don't have to worry about that, right? In that case, it's half of 1, half of 3 is here. It's better than 2 here, okay? Usually, you don't have this, okay? So we don't need to worry about the risk, but this is the shape, right? And probably you ask, this is the case, or risk aversion is the case where the bet is substantial enough, right? So that you'll be risk averse, right? You'd rather pay safe, right? And risk loving may be you're thinking about remember lottery, right? You are making a small bet, but there's a huge probability you get a lot of money, right? Maybe looking about a Bitcoin, a speculation, right? You just maybe lost a little bit, but it's huge gain potential. You may want to buy it, okay? But we don't need to worry about this part, okay? And very quick thing about risk aversion, okay? And how to measure it. Usually people look at starting from the what we call the St. Petersburg paradox. Okay? It's saying that if you toss a coin, okay? If you get a tail, you get $2. The first one is tail. If you head, go to second round. If second have tail, you get $4. Okay? If it's head again, go to the next round. If it is tail, you get $8. Okay? So on and so forth. Right? So if you try to look at the expected value of this, turn out to be infinite. Okay? And if you try to ask people how much you would want to pay, right? And usually the number is less than $8. Okay? And historically, later you will see, this is the reason why people propose your utility is a log function. That fit very well for this one. So your utility u of x is log of x. So log is this shape, right? People know the log. So later we'll try to argue, but this is one of the reasons why in the early literature, people look at the utility, look at uncertainty about money, take log. Okay? Here we want to mention one important metrics, probably you learned it in finance as well, we call the absolute risk aversion. Okay? Why we need that later, you'll be very clear. But the idea is we try to capture how people are risk averse. Okay? And the idea is rather simple, right? And basically look at this graph, right? The more concave you are, the more risk averse you are, right? If you know the math, the concavity is measured by the second derivative, right? The u double prime. Okay. Okay. And the way that we look at the utility, okay, would be the same if you multiply everything by some constant. Same preference. Okay, so that's why the measure proposed by what we call the arrow path measure is like this. Okay, it's just the second derivative over the first derivative. Okay? And basically just concavity, how concave is. If you don't want to remember the math, since we're not math class, I'm not going to require to know the derivative, but you need to know this. What is it measuring? It's a curvature normalized by the first derivative, right? The shape. Okay. And why is it important? Okay. Why is it important? Okay. So remember, you were concave. Concave is positive, right? So if you're concave, which is risk averse, this is negative number. Okay. So that's why negative is risk averse, 0 is risk neutral, bigger than 0 is risk loving. Okay. And why we talk about all these technical assumption here? Okay. It's just because this RA, risk aversion, can depend on how much money you have, right? In general, right? Because as I said, if you got a lot of money, you probably don't care about risk that much, right? If you have less money, you care about a little bit more. Okay? And in general, okay, how we would make the model simple to solve is to make that regardless of how much money you got, your risk aversion is the same. Okay? Assuming, say, suppose you have $1 million, you take the bet, will be same as you have $1 billion, take the same bet, no difference. Okay? If you assume people in this way, we'll call the Kara with according to this shape. Okay? And this is something you would see in the literature is negative exponential. It's just like it's still concave shape. Okay? This is what we have. Okay? And some of you will complain this is not true usually, right? Because you imagine that if you have more money, you're getting less risk averse, right? So Bill Gates would be much less risk averse than us, right? He's willing to take a much more willing to take a risk, right? So that's why in finance, you seldom see this one. Rather, you will consider other risk measure is what we call the relative risk aversion. Okay. The way to do is to multiply this by x. Okay. And what does that mean? It simply just means very simple thing is not your risk is not based on the absolute value of the gamble. Rather, you think about percentage of your wealth, right? For Bill Gates, he bet 10% of his wealth. I bet 10% of wealth. We have the same risk aversion. Okay. So if I bet 1%, he bet 1%. We have the same risk aversion. Okay. Put it this way. Okay. Bill Gates have $1 billion. I have $10. Okay. And suppose Bill Gates ask him to bet 10% of his wealth. If he win, he get double. If he don't win, he lose that amount. Ask me 10% of my wealth. Half the time I win, half the time I lose. And I am him the same. Okay? Just in terms of percentage of wealth, the same. Okay? So this is an assumption that usually you would take. Okay, it's normalized by that. And if this assumption is right, okay, that's what you have. Okay, we argue that the log is the thing you see in the math. Okay, which we'll use it very soon when we talk about the asset pricing model. So to remind you, this log function we'll use very soon, and this raised to the power also we'll use all the time. So this two functions we'll be using. Okay, and that's the reason why I talk about this mathematical definition. It's not because I like the math, it's because you will see them. Okay, in all the math declaration. Although we don't ask you to do it, but you know how they come about. The assumption behind is we assume people, regardless of wealth, as long as they're asked to bet according to the percentage of wealth, they should be the same. Okay? No matter I and Bill Gates, as long as we asked to bet 1% of wealth, we will be the same. Okay? This is a good assumption, working assumption in the finance. Okay? Of course, you can relax them, but this is the standard thing we see. Okay? And we'll need the risk premium because we need to define them. Okay? What is risk premium? Risk premium is, probably many of you would know, is you need to, how much you need to pay that guy in order to take the risk, right? So we start the guy with the wealth W. Okay? If we ask him to take the lottery, okay, and we have taken away the risk premium, this pi, will be same as you the wealth start give him the expected value of lottery. Okay, that the pi is the risk premium, right? Because if you're risk averse, you want to take this one rather than this guy, right? You subtract from that is the risk premium. Okay, the risk premium is defined in this way, but probably you would like to see the graph maybe easier in this way. Okay, this is the graph. So you have lottery 1 and 3 equal likely. Okay, so that means that if I ask you to take the lottery, if you follow this utility, how you like this lottery is this number, right? This is the number that you like this lottery. Okay, you tell me this is your utility. Okay, if I say, okay, let's don't pay this lottery, I pay you $2 directly, you will be happy, right? Because your utility is here. Right? So the question is how much, okay? What the first thing is what we define, I should have defined that as well. It's called the certainty equivalent, which is saying that I give you this money, you don't want to pay lottery. So this is the certainty equivalent. And the difference between these two will be the risk premium. Why? Okay. If I give you this value, okay, you are same as you taking the lottery, right? And this is the part, right? I have to pay you in order for you to take the lottery. That's a risk premium. Is that clear? So later you will see in the pricing equation what is the risk premium we will define. Okay? So I guess it's almost, I mean, the rest is very simple, but So that's why I want to take a break, but because that's the definition from that on. So let me break of 15 minutes, and when we come back, we will doing the second part of intertemporal choice. Then we can give you more interesting, funny pricing equation later. Okay, so so let's have a break. In the meantime, I would start the U reply. You can tell me how well you think.唔考，我寫 math 就係唔考嘅，但我要講出嚟，你先知道咩嚟㗎嘛。
明白，即係可能到時嗰啲 case，但係要理解個 concept 係。
我唔係呢個 concept 主要係解釋下後邊點解我哋要咁樣定義。
明白。
俾個 foundation 嚟咁解啫。如果唔係，你話點解呢個係咁啊？咁你又解釋唔到㗎嘛？係咪？我唔能夠話你係信我啦，呢嚿嘢係咁做咁啊咁做咁啊，變咗唔係咁啊，變咗教 finance 教佢咩 foundation 嚟咁解。
明白，好。
即係話你講緊嗰個人係我哋主要講句就係話，佢講嗰個人係對於相同嘅百分比嗰個風險係一樣嘅，無論你係標機好佢好到10%，佢10%，無論幾多錢都好，佢都一樣。OK。呢個係咪人大個 expected？ 係啊，因為有你有50%機會1，50%3，咁你嘅中間咪呢個。但係因為我見即係譬如 risk loving 呢度咁，即係佢個 expected 係啊高過你正常㗎，所以升到嘛。但係如果呢個點解又話係 risk loving 就話你賭錢多過你嘅 FINA？ 但係咁點解會係大過 expected？ 呢個係咁呢個喺個上面。呢個係 expected lottery 咩？但係呢個唔係話呢個就係 average 咯。U of L 就係一半嘅1，一半嘅3咯。即係呢個 expected 就係2咯，因為呢個 expected value of lottery，E of L 就係 E of L 係咁樣 define 㗎嘛。唔係就係 E of L 就係你個 average value， 唔理佢就係直接乘啊嘛，就係2蚊。
我公司咧下個星期6會喺杭州搞策略會，因為我要去。冇問題啊，所以上唔到堂，所以想要請假。我同個 Kelvin 講，咁再同你嗰個講啫。
有 quiz 嘅話就會，我哋會搞個 quiz model choice 嘅，咁你咪可以冧到加埋到即係兩個一齊。
會唔會 high risk 咧？
唔會 multiple choice。
你都係變咗
A B C D 啫。
咁你變咗1份變咗20%，同1份10%。
A B C D。
嗰個 Kelvin 嚟㗎嘛？
唔係 Kelvin separate。
哦，即係個第二個 quiz 就係1同2中間嗰啲 topic。係。
唔係都係 concept 同嘅，即係譬如問你以下邊個又係 risk averse 啊？
哦 OK，
即係 open book 㗎嘛。
OK， 好，咁我再 send email 俾你。
OK。
我想問下你呢個咧，即係話如果你做咗網絡嗰陣時，
因為你嗰個 function 係咁㗎嘛。你個 function 睇呢個 function 咁咪即係話你乘呢個乘5，呢個乘5都一樣㗎嘛。
咁但係我意思係話，咁你做咗網絡之後，
我哋唔係你就咁㗎嘛。嗱，你有個 stock，你同 stock Y，咁你嘅 utility 嘅 U， 咁你咪記咗3個4，咁你乘咗幾多倍嘅3倍乘嘅話 V， 咁你乘咗3都係6同埋8都一樣。
即係我意思係話，因為如果例如我有 stock X 同埋 stock Y 啦，即係 UX 大過 UY 咯。
係啊。
咁如果咁假設如果我又要 X 加5個2車，應該都係大過 2X 或者 㗎。
哦，唔係咁樣 transform 呢個，唔係 transform 呢個，唔係 transform 呢個嘢，係話如果 V 係等於3V 加4，我睇唔明啊，譬如話你幅圖咁啦，如果聽你咁嘅，譬如話摩通就話，譬如話你乘咗3倍，再往上加2，呢個一樣。
即係淨係影響佢 first order condition，
唔係因為 shape 唔係，淨係應該 shape。譬如話，我簡單嚟講，
即係個 first order condition
即係咁樣，一個係2啦，咁樣叫咩？
即係就
唔係講緊你個
disturb 佢，
唔係 disturb lottery， 係 disturb 呢個 utility representation。你唔係改緊，你咁樣改緊 lottery 係第二樣嘢。lottery 唔變，你淨係改你點樣俾個 number 佢嘅啫，因為 utility 俾個 number 俾個數字，每一個 lottery 俾個數字佢啊嘛，係咪？明白。好簡單，係咪呢度？唔係，因為 lottery。但係如果你話 higher value indicator greater risk value， 係 absolute， 會 absolute。因為如果俾呢個俾啲運程啦，其實呢個就係係啊，越嚟越滾嘅。你想 因為你俾2蚊你，你爽啲。但係如果叫你俾1蚊同3蚊佢哋，工時咧就得你嘅就慘啲嘅得咁低。你俾2蚊你，你俾2蚊你。O.K. 我明白你講嘅嘢，係咯，但係我會覺得你講得啱，但係我哋講即係按摩係開複雜嘅嘢，咁但係簡化嚟講就係解決價錢，而家見到啦，我炒緊嗰個工時即係話，如果譬如話只要我攞相機過嚟，根據根據即係譬如話講緊我100蚊，我10蚊，我增加10蚊，即係我賭錢，贏嗰個贏1蚊，贏嗰1蚊輸1蚊咁解。佢嚟講你贏一人10蚊，輸贏10蚊，輸10蚊，咁咧我必要驚佢。但係現將來複雜啲咧係有，但係咁我哋就會，我哋先明白得最簡單嘅情況。我同意講嘅情況，但係我哋明白嗰個地方最簡單嘅情況，唔係都點樣 work 啊？咁你複雜啲嗰啲就係我哋話最簡單。你見到我哋頭先開始成堂去咁簡單咯，好簡單嘅，其實你嗰幾錢？你嗰啲嘢少啲道理嘅，有啲唔簡單嘅。咁見到 view 嗰間就好啦。其他凡係新嘅，確實嘅。如果有個 app 就話你幾多錢都係10蚊都係。係啦，就係先卡嘅，有時會有呢啲嗰個低嘅。如果大家都好有錢嘅咁啦，咩講譬如話買到彩咪就咁啦，就 best 細，best 大，但係 financial 呢個輸咗呢個，因為你講下個 financial 咁樣可以點解？關鍵係點樣幫你關鍵固定關鍵。但係你可以話走嘅，你改咗點講？咁啊簡單簡爆。我都緊張。咁即係我哋簡單嚟講，有咁大分別，咁你睇到佢打好運。大家都呢個地球，如果你眼中個係多嘅信號，咁你睇到好啲 C rate 咁樣做。即係簡單嚟講，佢用呢個 model 最簡單可以2歲5分嘅。我再帶你講講緊呢個 model， 發現佢。
So let's see how we're doing today. Oh. So looks terrible. Not sure is it my cause or other reason. I hope it's not my cause, but let's see how well you're doing for the other one. It's okay, maybe slightly little bit too fast, I don't know, but we are reviewing half of them are reviewing what we have done 2 weeks ago. So far, okay. Oh, wanted to learn about St. Peter gambling theory. So that is actually St. Peter's paradox. I don't think we have too much gambling theory here, but that St. Peter's paradox actually preclude what we have expected utility, right? Because at that time when they do that, people think about log utility, okay? And that's why people think about in the log terms, right? So I guess that would be try to answer that question. Let's gamble, okay? So you must be risk loving, which, as I said, if you are protected by limited liability, you will be risk loving, right? You only gain when you win, you lose, you just other people money, right? So that is the thing. U double prime, as I said, our class is not math, but I need to put the math there because some of you ask what it is, what's a curvature, right? But we are not intended to ask you the math, okay? Just if you know, you know, you don't know, doesn't really matter. It doesn't affect our understanding. But some argument we make is like this is because we need to assume the curvature remain the same, right? Okay. Why lateral knock? Very good question. So I can only answer you in technical term. So why lateral knock is because if this is a constant, this is a differential equation, you can actually see, you can solve the differential equation, this gives you the law. That's a short answer if you learn the differential equation. But, and other reason is the log function coming from the St. Petersburg paradox fit very well. I think that's a better answer. But from the math, that is from the math. So that's why, yeah, that's it. Because if you load the math, you should take the log function. You take this, it's 1 over x, right? 1 over x squared, so that's why it's always constant. So that fit, okay? But I'm not going to talk about more of that because then it becomes math class, right? But I'm just saying that when you log, right, the log function look like this, right? X, log x, something like that, right? So this is the shape that we are looking at. Okay. And this is what I think you have learned it also in your finance class as well, right? I don't know, but if you try to look at your portfolio, okay? I mean, in the undergrad, in the investment class, right? You probably want to look at, say, okay, stock X, right? With probability 0.5, 0.8, you get some amount of money, maybe $10, right? 0.2, you get $5, right? Then how you evaluate, maybe we just this multiplied by this, and calculate mean and variance, right? And then why this holds, right? So we'll give you the reason why this is true very soon, okay? But let me go to that slide after a few slides we want to discuss. We'll give you the reason why you do investment in your first semester makes sense. Anyone buy Mark 6 together? I get this is very good behavior, right? Because Mark 6 is a risk loving, but you also want to take some insurance, right? You just buy together. When you lost, everyone share, right? Because everyone combine money to buy, right? You lose the part of it, right? Combine money to buy Mark 6 is actually a nice behavior, right? Actually, you're still risk averse anyway. Can I have what is bingo? Or bingo? Oh, eat hot pot in the class? Yeah, I don't know. TT. Okay. Can we have some volunteer MC question to check concept? What do you mean by volunteer? You mean I should give some sample question? Is it something like that? Oh, sample question. I will give some sample question. Sample question is something like the next week we have a quiz, but the quiz is like very simple. checking concept, like the following. Say, if you are going to, if a person buy a lottery, is it risk neutral, risk averse, or risk loving? Something like that. Or I'll give some sample there. Okay, don't worry. So it's just like you bring your slides, then you should be able to answer. Horse racing is not risk averse, it's risk loving. You buy horse racing. But if you do horse racing, it's actually risk loving. Anyway, I don't know, horse racing is not risk aversion. I am risk lover to migrate in this course. Oh, if you're risk lover, maybe you can skip the quiz 1 and do quiz 2 only. Then everything divided on quiz 2. Is there any risk lover here? I can combine. I mean, that's fine. I mean, you skip the quiz 2. You can do that. Don't worry, the math we'll keep it minimal, so we are just math just for description of the concept. So we are not intended to ask you math anyway. Okay. Of course, some number calculations needed. Okay. Okay. I try to keep the math minimal, but some math will be needed. Otherwise, I can't tell things. So here is some concept that I want to give you, but they are not super important for your purpose. Okay, but they actually use a lot of time. But I just want to mention. The first one is I would say rather trivial, is what we call first order stochastic dominance, which means that if I give you 2 lottery, okay, can I tell if everyone would like the first one or second one, regardless of risk preference? Okay? Yes, you have. If the first lottery always give your money, then the second one. Right? That's what we mean by first order stochastic dominance. Okay? Means that whether you're risk loving, you're risk averse, it doesn't really matter. Right? Suppose the first lottery, I give you get 1 million for sure. For second lottery, you only get half of the time, you get 1 million, half of the time you get $500,000. Then you like the first over the second. Right? So I think this is a negative result, right? Which means that you can't really tell how people make decisions unless you know the risk preference, right? And that actually what underlying you see in the financial planning, right? You need to know the client before you make any judgment, right? So the first thing. The second one is something that is familiar to you when you do investment class. Okay. The second means, okay, we can't really tell if you give you 2 lottery, everyone must like the first or the second, regardless of risk preference. But can we restrict our comparison only to risk averse people? Okay. Consider the case, everyone is risk averse. Okay. Look at 2 list lottery. Can we say no matter how risk averse you are, you always prefer one or the other? Okay. The answer turned out to be very simple. Is if the 2 lottery have the same mean, the first one have lower variance, then no matter what is your risk preference, how risk averse you are, as long as risk averse, you prefer the first one. You always prefer the one have lower variance. Okay, same as what I said. If I give you $2, compared to the case, half of the time you get 3, half of the time you get 1. No matter what risk preference you are, as long as you're risk averse, you always take $2 rather than take a gamble. Is that clear? So that is what we call the second order stochastic dominance. What does that mean? It means that, look at the investment idea, right? You learn that the efficient frontier, right? If you remember the frontier. Okay. Disclaimer, I'm not teaching investment. So just a quick question. Remember how to do efficient frontier? What is the x-axis? Hey, you give everything to your professor back? What's the x-axis? Risk, right? And risk, how we measure that? The deviation. And what is the y? What, sorry? Return, maybe mu, right? And basically, there are many things you can do, right? And usually, pick out something like that, right? And why this is frontier? Why you compare this point A, this point B, why A better than B, right? And also C here, right? Of course, A is not doable. Maybe easier case is look at the frontier A and this inside B. Why equal A is the good thing. Is that clear? Is that clear from this side? Yeah. Why A is better? Here. Okay, dominance. Same expected payoff. The variance is higher at the worst. And it is regardless of your risk preference, as long as the risk averse, right? But of course, if you're risk loving, then you're not picking this one, right? You will pick the inside rather than the frontier. Is that clear? So when we talk about this already, we assume risk preference here. Okay. So I think that would tell you, right, some idea why you do the mean variance minimizer. Okay. But I'll give you more. But this is the first thing. Okay. The first thing comes out from these two concepts. Okay. And of course, as I said, right, that's why you do diversification, right? You never put the egg in the same basket, rather you separate them, right? So diversification is only if you're risk averse, right? You tell people why you diversify, because I'm risk averse. But some of you said they're risk loving, right? Right? So put all the egg in the same basket, right? Don't take quiz 1, only take quiz 2, then you're done. Or skip quiz 1 and quiz 2, take the exam, right? But of course, you have to have legitimate reason to not to take the quiz, right? Is that okay? So that actually explains a lot of things in the real world, why you see hedging, why you do leverage. I guess many of you experts, I'm not going to go to this, it's just verbal description, right? Why you have derivative market, right? Why you want to swap, right? Because you want to cancel the risk, right? I guess this part I'm okay to skip because it's verbal. Is that okay? I mean, I'm not going to go one by one because that is very verbal thing. Not I skip this slide, but I save the time to do more important stuff. Okay? Okay? This slide is not skipped, okay? I just not talk about that because I think you can just read it without I talk about that. The next one is why we buy insurance, okay? Because we're risk averse, that's why I buy insurance, right? And that's why insurance company also buy insurance, right? That's reinsurance because they also risk averse anyway in some point, right? Because insurance company, right, basically they locate in certain area, right? The risk is still related in Hong Kong, right? So that's why there's a reinsurance company that sell insurance to insurance company around the world, unless a alien comes, otherwise it doesn't affect the whole world, right? So that is something there, but I'm not going to go to detail on that one. Rather, I want to draw your attention to this one. Okay. The reason I want to draw attention on this one is in the investment class, you learn about people care about mean and variance, and you ask why. Okay, and there are two defense for that one. The classical defense is what we call contracted utility. Okay, your utility of your money is have two parts. One is linear in x. The other is negative 2 square, contracted. If people behave in this way, I'm not going to show the proof. In that case, people only care about mean and variance. Okay, and probably you ask, what other than mean and variance, right? And you learn from statistics, there are many things more than mean and variance, right? The kurtosis, skewness, so on and so forth. Right? Why I don't care about that, right? And why just mean and variance, right? Why I don't care about median, quartile, why never care about those, right? If you behave in this way, that's the case. And second is something often we have in many of finance one, right? Many of you know the Black-Scholes model and so on and so forth, right? They assume the uncertainty follow a bell curve. And normal is a bell, right? I hope everyone knows bell, right? Bell curve, right? If the stock return follow the bell curve, the stock price follow the bell curve, and if your Cara like this one, okay, not the CARA, not CRA, right? This, then you would be your utility only care about the mean minus half of your risk preference. This is the absolute risk aversion times this guy, right? And this is how usually you see a lot of models. Just let's start with this guy. That's why they call the mean variance minimizer or optimizer. Okay, there's the assumption if you do CFA, right? You know the Black-Scholes model, right? They actually assume normal, right? And of course, these days, normal assumption is not really good. People would use normal or other thing. But anyway, let's tell you why we have this, right? In the investment class, you do that, right? That's how you do you choose the access management, right? Am I right? I mean, I don't know whether you do it, but this is the textbook formula. If you learn the investment class do you learn that in your first semester? So anyway, if you forget, you just go back and check. This is how you do it, right? The more risk averse, then you will deduct more from your variance. Do you? No? Then what are you learning? Okay, this is how you would think in your investment class, right? Your utility funds are like this, right? This is the point. Anyway, whatever. I mean, so what I want to say is, now I give you the foundation in undergrad why we only care about mean and variance. Okay? Of course, this is pretty restrictive, but at least we tell you that there's some reason how we come from preference lottery all the way to here, we care about mean and variance. Okay? Because this classes give you the foundation for finance practice, right? Otherwise, how you get this formula? How you from here to turn out, right? Because remember how we do investment class, right? You look at different portfolio, calculate different mean, different variance. This gives you the measure, the metrics of how this portfolio works, right? That's how you do. Okay? But don't worry, we are not investment class. I'm not going to ask you in the quiz, calculate this. I'm not going to do it. But I give the foundation for that, okay? So don't worry about that. I'm not asking you to do the financial calculation for that one. Okay? Is that okay? Any question before we proceed? So that is the framework that used in classical finance or investment class. That is, you don't care about skewness kurtosis. Okay? And as I told you, recent 5 to 10 years, actually we are taking this into account. We care about skewness and kurtosis. As data shows, that is the case. Right? But this is out of our scope. Just to remind you, this you have been doing, right? Just give the foundation why this is true. Okay. Now we have intertemporal choice, and this one we will try to explain one thing in our mind is return. Okay, we're going to explain the return or interest rate or the okay. So it's very simple. It's very similar to what the model is very simple. It's similar to what we learned in the first class. Okay, the model is very simple in the sense that an individual is choosing to consume now or tomorrow. Okay, only two things: is consumption of today or tomorrow. And the question is, what's trade-off? Okay, if you spend more money today, you have less money tomorrow. That's it, right? Only trade-off. And if you don't, just the simplest thing is imagine that you're in the island, right? There's an apple in the tree, right? If you eat today, the apple is smaller. If you don't eat it, they got the sunshine, bigger. Okay? The question is, you eat now or eat tomorrow? Very simple question. Okay? And the sunshine getting bigger depends on the sun, right? And we assume that we look at the sky, we know whether how big the apple will be tomorrow. There's no uncertainty in this model. Just in the temporal choice, okay? We move away the uncertainty at the moment. We just think about today and tomorrow. We know the perfect world, how the sunshine, how the apple become bigger or smaller. Okay? So the model is very simple, as I said. Now you have a income, I, it's just number of apples on the tree. Okay? And if you don't eat all the apple, okay? If you eat, okay, it's called C1, how much you consume, how many apple you eat. What you left, you get more tomorrow, right? Because the sunshine get the apple bigger, right? Is that clear? Okay. R is how it get bigger. You can imagine R is the return, right? But of course, you can imagine this R will later is the interest rate or the investment return, right? So in this model, right, the individual only consider how much you eat today or tomorrow, right? Because after tomorrow, everyone dies, end of the world. There's no, you have to eat everything, right? Otherwise, you waste money, right? So what you totally, your consumption is like this. How much of today, right? And tomorrow, discount the present value, same as I. So this is the lifetime budget. Is that clear? Okay. Your choice is have to choose C1 and C2, right? And depend on your preference. Okay. Of course, if you only like to consume everything, C1 is very large, then you just eat everything today. Tomorrow you die, doesn't matter. Right? Depends, right? Or you are the one who care about future, you're very patient, then you consume nothing today, you consume a lot tomorrow. Okay? And how much the trade-off today or tomorrow is the essential thing about this investment return, R, right? Because the sunshine get bigger, right? That's investment return, right? So what's the optimal choice here? Think about the following. If you eat one apple a day today, then you lose one apple, right? But if you eat one apple tomorrow, there's less than one apple, right? Because the apple get bigger, right? The cost of eating apple tomorrow, one apple is not one, it's less than one. It's 1 over 1 plus R. That's the growth rate. Is that clear for this one? Is that okay? Say suppose R is 100%, say 1 apple become 2 apple, right? R is 100%, right? In that case, eating 1 apple today is 1 apple, but eating 1 apple tomorrow is just half apple, right? Because half apple become 1 apple, right? If R is 1, double, right? So it's just 1 over 1 plus R. Is that clear? Now look at the relative price ratio, right? The price ratio is 1 over 1 plus R is 1 plus R, right? The trade-off, right? And remember, in the topic 2, right? How people behave is to trade off in the head, inside and outside, right? Inside in his head is the MRS, right? The marginal utility. How you think you give up today 1 apple, how many apple tomorrow you need to make you same happiness, right? And optimal will have the same thing, right? If this doesn't make you recall, this is a graph, right? The optimal condition, okay? If you eat all the apple today, that's I. If you eat all the apple, it's I minus 1 minus R. Anything in between is feasible, right? So this line is the budget line, right? You basically choose everything here to be good, right? And this is indifference curve. There are many of them, right? What's the best one? Turn out with the one that's tangent. Why? Because in here, suppose this is suppose you choose this one, right? And that means that you can actually reduce your consumption on period 1 and get sum of 2, you get same happiness, but you can get more, right? So you would just keep reducing until there's nothing you can do. Okay? So though this is the optimal saving or optimal consumption, what does it tell us? Okay? So we can't go further without making further assumption here, except saying the MRS is just give the interest rate, right? So basically, from this basic model, what we know is the following, right? What is the investment return or the interest rate, right? Or is based on how people think about tomorrow and today, right? So if I think tomorrow is very important, the interest rate will be higher, right? And for example, if tomorrow we expect no money, poor, recession, some money is good, right? Then the interest rate will go, right? So that will be how you think about tomorrow today, right? If you think that is the MRS, right? If you think tomorrow is more important, interest rate goes up, right? If tomorrow is not important, you don't care about the future, the interest rate is very low. Okay. Now, but let's go into give you more detail. Okay. Let's do the following. So this is very standard way to think about future trade-off. Is what we call the time separable utility. So you look at the future, okay, today and tomorrow. You're going to make the following thing is you are looking at separate today and tomorrow and a discount factor. Okay, this is very standard. Okay, and I'm not going to give you why this is true. There's some other assumption there, but this is the something that we often use it. Okay, we can separate today and tomorrow. Okay. And under this assumption, okay, what is the MRS? Right? How you think your head trade off 1 and 2? So this one, right? This is you give how much you give up 1 apple today, right? This is how much you give up the apple tomorrow. The ratio is the exchange rate in your head, right? Because you would discount beta, right? Beta is less than 1, right? 0 to 1, right? And this is the fundamental formula, right? We'll give a little bit one more step. So, but this is the first important formula we have here. Okay. Now, based on this formula, okay, you say, okay, still complicated. Okay, can we go a little bit further? Okay. One thing is we assume log utility or power utility. Remember they are Cara, right? This Cara, right? And this log is the case we mentioned, and power is a special case, but it's a general case of the log. Okay? If you take gamma to 1, then it's a log. Okay? But anyway, so under the log utility, the marginal log is just 1 over c. Okay? And this basic math thing, you don't need to memorize. I mean, just tell you this as a fact. Okay? And oh, sorry, say typo, small typo here. There's a beta here. Sorry. Okay. And you do this, okay? Sorry, typo here. So typo, okay? So if you write this is the formula here, okay? What is the market interest rate? Market interest rate is actually given by 2 components here. One is how people view the future, discount the future, on beta. Okay? And the other is consumption growth, C2 over C1. Okay? What does that mean? The first part is how people look at the future, right? If the usually it's stable, right? But of course, if they think tomorrow we go to war and so on and so forth, right? Discount beta will be very small, right? Whether they look at forward-looking or not. But this one, C2 over C1, is consumption of tomorrow today, right? Is economic growth, GDP macro problem, a macro issue, right? You think tomorrow is good, right? This will be large, right? Of course, tomorrow GDP depend on a lot of things, right? How technology growth and all the things. But interest rate is determined by the patience and also economic growth, right? So that is how the interest rate or the investment return being determined in general, right? The basic model, right? Is that clear? Now, if you look at the other equation, I'm sorry for the typo. Okay. And if you take the power form, then interest rate, right, is again the growth raised to the gamma, okay? And remember gamma reflecting how risk averse people are, the log utility, right? And this is interest rate, okay? Or interest rate or investment return, okay? And I think this is give you the foundation for interest rate, right? Okay. So the interest rate, if you think the market is efficient, the interest rate you see in the bond market reflecting how people view the future, assuming the beta is a constant, right? Because usually beta don't change a lot over day, overnight, right? And how the interest rate change actually tells how people view about the future, right? If you think you use the bond market to elicit people's expectation, right? Or other way around, if you think you're smart, you can predict the economy better than others, you can win the bond market, right? You can tell whether the interest rate should go up or go down, okay? But this will tell you in a very simple, I don't know, very simple, but the basic model telling you what is investment return there. It's determined by how people trade off today and tomorrow. Okay? We'll give you more, don't worry. This is the basic thing, we'll give you more equation. But this is the simplest equation we have right now. Is that okay for this one? Okay? And before the break, I want to talk about this slide without going into detail, is what happens if you have uncertainty, which is you care because of finance, okay? And that doesn't change much. What you change is you have an E sign, which is expectation, right? So, which we'll derive later, okay? But what it turns out, it basically it's still the same formula here, okay? So how do I see that? Let me show you. How do I derive that? Okay. This is formula we'll derive, okay? And in particular, okay, this is the thing we have before, right? And this is the discount factor, and this is 1 minus R. And later you will see this is different from the classical approach in the finance. Your classical approach in finance is you discount the future only by beta, right? Okay. And in the what we call the consumption-based asset pricing approach, your discount future not just based on beta. You have to discount based on your consumption ratio, MRS. Okay, it's not the beta, but the MRS itself. So that's why this guy is known as what we call the stochastic discount factor, SDF. And we don't talk about this, but modern asset pricing, everything is deal with this guy. Okay, it's not, if you learn asset pricing, I think in the advanced class, they will deal with this guy. Okay, the discount factor, just to emphasize before the break, is you don't discount the future just by beta. Okay, that's the case. It's true if your consumption over a period is constant. If you consume the same over all the period, you discount the future by beta. That's very simple. But turn out that you would care about how economic growth, how economy changing, affecting this. Okay, so you discount the future also based on future consumption, right? Why you care? Because tomorrow is a recession, right? You may be consuming less, right? And if you consume less, C2 likely to be lower, right? And this utility, remember, you always diminishing utility, is also concave, right? Although we talk that in the certain world, right? Even if you are certain world, your utility is concave. Why? Because if you have one apple, give you one apple is very happy, right? You have 10 apple, give you one more apple is not so happy, right? Suppose you give me 1 million, I'll be very happy. You give Bill Gates 1 million, nothing changes, right? It is very small, so it's concave. So in that case, if tomorrow this is lower, this is very high, right? So you would discount a lot. Okay, but we will talk about this after the break. But our break will talk about this formula, okay? And just preview at the end of the day, okay? We will, after the last, at the end, we will give you this beta pricing equation. Okay, this will cover the break is why you get a cap M, how we can get a simple cap M model based on consumption. And this cap M model is different from the mean variance approach. Okay, and we explain why this is different. Okay, and this is what the modern consumption cap M model. Okay, I just give you the basics, so you will learn more in other classes. Okay, but let's have a break of 15 minutes and we come back. Don't worry, you cover this. I just give preview only.
呢個細個嚟睇啊 first 我 get 啊，點去翻呢度啊？咁你呢個係上咪負啊嘛，咁咪應該正咯，咁咪正先應該係。
係應該正嘅，係咯，
咁咪
係冇錯。
好明呢一個係咩嚟㗎？
哦，即係話好簡單，你個睇個 future 嗰時好多嘢㗎嘛，C1 咁你可以係 C1 開東寫法㗎嘛。咁我而家就係話咧，睇譬如話今日嘅蘋果同聽日蘋果。C 係一定係聽日嘅，代表將來。我而家 model 聽日評論啦，我個 model 得兩日啫。咁我而家個 model 嘅樣寫，就譬如 log C1 加 beta 嘅 log。
我想知呢一條嘅意思係我確實
即係譬如話，今日我食3個蘋果，即係食4個蘋果，你嘅 tipping 就係咁咯 ，log 3加 beta 5就係 log 4。如果你細3，咁就咁。你話 beta 係你自己嘅 subjective discount 係0.9啊、0.8、0.9啊、0.9。點解一定係0.1？你中意早啲食啊，定係晏啲食咧？人都係 impatient 嘅。譬如話咁啦，而家攞10蚊定聽攞10蚊，你食爽咩？係咯，咁所以你容易攤細啲。自己咁樣啊，即係 beta 要1加咁啊，呢個有唔同噶嘛？你係未來嗰個係少啲噶嘛？即係可唔可以話 over 1加beta 等於1除以1加唔等於即係 R 係咩咧 ？R 即係點解 ？R 嘅話咧就係 interest rate 啊嘛，但係 beta 唔一定 interest rate 咯。但係譬如你，呢個就係講你喺正常嘅情況之下，你喺 investment class 嗰陣時，或者喺 undergrad 嗰陣時，會話哦 beta 就優過 R。咁呢個咧係一個我哋 undergrad 但係唔係啱嘅，即係你 patience 應該 in general， 譬如話你 undergrad 就話 market interest rate 係咩啊？我哋嘅 patience 一樣噶嘛。咁但係呢個其實我一講咧係唔啱嘅，因為你嘅 utility 唔係 linear。如果你嘅 utility linear 就係，如果你嘅 U 你冇點樣需要睇，如果你嘅 U C1 加 C2係等於 C1 加 C2，咁咪得咯。咁就係啦，你呢個咪一。 嗱，即係嗱，簡單嚟講，我講咗啲咩咧？呢度你傳統上咧喺 undergrad 嗰陣時就會咁講噶嘛。你個 utility C 或者 C 你係淨係話，哦，你淨係咁樣 discount 啫嘛，就俾beta。你個 indifference curve 就係 C 1加 beta 嘅 C， 咁呢個係唔好正確噶嘛。你應該因為你個正常嚟講，你有 utility 係點噶嘛？因為你有 diminishing return 噶嘛，即係今日俾多1蚊你，同埋聽日俾1蚊你唔同噶嘛。或者同埋你係有100萬俾1蚊你，或者1000萬俾1蚊你，係唔同噶嘛。咁所以你講緊呢個 market 個 interest rate 唔係 reflect 緊個 patience， 唔止 reflect 係要加埋你對未來經濟嘅預期。所以你嘅 interest rate 唔係淨係 patience only，also economic growth 如果 effect。咁所以後邊如果有咁樣先可以計到所以點解會係有 pricing equation？ OK， 你第一個問題係點樣 estimate 呢？
唔係你嗱，其實你個 patient 係呢個基本㗎嘛 ，market
哦，呢個 under 嗰陣時會教，呢個係咁嘅嘢。呢個呢邊係咩？就係話，哦，你嘅 market interest rate 咧就係點埋 patience， 就 under 佢學㗎嘛。
而家就係呢一個。
而家話咁係唔夠嘅，唔夠，你係要加翻 C。即係話 under 你學嗰陣時你冇呢個嘢㗎嘛？你嘅 interest rate 係 independent of the role。C 同 C1咧係 macro 就係你對，譬如話你今日使嘅，今日可以食咗幾多蘋果，食咗蘋果係由呢個 general economy 嚟㗎嘛。聽話咧幾多錢，聽話咧幾多錢係經濟決定㗎嘛。啊，冇錯，我哋同埋咧咁樣 macro 咯，你講 macro。所以其實呢個係一個叫 macro finance 嘅一個導向。我哋睇 finance 唔係就咁，即係 macro 就係要睇翻 macro。呢個個 foundation 就哦，個 interest rate 咧就唔係淨係個 basis 咁簡單。所以係 reflect 緊大家對將來嘅 economic as well as basis。
嗱，你話呢個係 expected GDP，而家 GDP 啦。咁其實如果我 expect 將來 GDP 低，咁其實我個 patient
你個 patient 唔變㗎，所以 patient 不變嘅，你個 utility 唔變。
所以變呢係
即係話你呢個你係要不變㗎嘛？
呢個係 assumption 嚟㗎啦，即係我冇得解釋嘅，點解？
正常我哋 assume 咧就係未來都係不變，如果乜都變咧就乜都做唔到嘅。唔係 K model beta 有啦，呢個 beta 第三世人。咁 K model 嘅 beta 就喺後邊度咯。我哋其實會講到呢個咯。咁個 beta 其實就係同呢個差唔多，係同呢個 beta 係你對於未來嘅 discount factor， 呢個 beta 即係呢個嚟。即係你對於未來嘅即係嗱，如果你係唔 care 而家同未來嘅，你邊個？就係嚟一個時間。越高嘅你對譬如老人家嘅，你嘅老人即係如果天同玩完嘅，如果你係好後生嘅飛行員，咁其實飛行係影響到個 age structure 係啊，所以電腦嘅喎，即係譬如話個數生係 aging，咁個飛行係即係上面呢度細咗㗎嘛，聽日好差啦，佢都唔係整翻再低啲，咁導致到即刻如果你間電即係或者即係話大家講即係飛大個差嘅，因為以前嘅感覺㗎嘛，飛大即係溫度嘅。即係係啦，其實
實唔知要問啲咩，我唔知我唔知啲咩。
嗰個目標又唔知喎，出嚟聽下。
唔係個人。其實咧兩個係嘅，我好中意你以前你學嗰陣時，你冇呢個，好多人係咪個個人都咁先？我而家同你講啊，呢個你喺度，你就除非你係咁，即係話我哋你冇聽到先算係影響到佢。如果你有嘅話，就到嗰陣9萬幾人，即係如果你係 U C 1加 C 係在 C 1加 B 咁你就唔多啲啦。飛行其實飛行係咁係即係到底有幾？即係我哋一講呢個 beta 呢個你呢個就做到㗎啦。interest 如果你嘅全世界 interest 你全世界都係咁你嘅 discount 喺度嘅。如果點解先會有嗰個 pricing 即係嗰個咁但係佢就係夠嘅，即係如果咁嘅話，你個 share 會用一世咁樣啊嘛。咁你做啊嘛，我係係啦，差唔多呢個啦，即係。
而家係佢呢一個我就真係呢個影響呢個，其實呢個係前提，即係呢個由呢一屆影響呢個。
都係咁嘅話，點解點解喐啫？大家都係
你唔可以話邊個影響？
你而家先有個 consumer 嘅角度，呢個係取決於你嘅 GDP 啊，
即係話個 technology 即係好似話你今日儲1蚊，咁你聽日
所以你可以
幾多錢？呢個
翻一個呢個 foundation，但係當我哋有 fluctuation action 一齊我哋去我哋冇理由話你諗下 interest 係咁喐，嗰個 beta 係咁，我哋買平呢個會考慮話我哋冇理由 price？點解我哋唔會考慮話我哋個 bond market interest？係因為我哋全世界都一齊喺度，係因為我哋 basic 咗嘅啫，個 price 好貴，唔咩就笠落咩就會影響到個 price。即係同我哋每個，即係你唔可以話邊個 depend 即係我哋有幾按我哋我哋自己係幾唔會幾耐性咯，係一個 variable 嚟嘅，一個係我哋。咁呢個會影響譬如話 A，我哋就因為個 interest rate 點解我哋就儲幾多個分鐘。但係如果當我哋全世界，如果你聽日玩完嘅，咁就會影響到佢。如果你聽日如果好鬼老嘅，咪飛行。如果啲學生飛行其實就係你做咗你係你自己。
阿 Michael 嚟講係
你自己有啲嘅，即係話你譬如話你而家諗下，如果大世界末日，你今日已經99歲啦，你唔 care 嗰啲所謂嘅，所以你個機場咪細咯。但係如果好似你係好後生嘅20零歲嘅，咁你驚退休啊嘛？你驚退休嘅時候，飛行咪特別高咯。你成你做100年都做呢個，所有反應都係呢個，所有都係唔相關。呢兩個其實係 depend on 你做緊做呢啲 choice 嘅嘢啊嘛，即係你個 choice 嘅 consumption 度咧，你會 allocate幾多係 consumption，咁我有幾多 consumption。
我呢個嘢通常呢個係 base，呢個我哋都比較少。當然佢你都做晒，唔好講變啦。你係有啲大家癲咗。
呢個好細嘅，咁即係你呢度唔 consume，呢度 consume 好多。
你簡單嚟講呢個
係啦，因為你唔 care about tomorrow 啊嘛，所以你 allocate 落去 tomorrow 嘅 consumption 就會少咯。
你 consumption 使幾錢啊嘛？你今日幾錢食飯？
我聽 professor 嘅解釋啦，包如果話我哋買嘅話咧，呢一個就係
點講咁多基本上都係。
呢一個就係咁呢個係會 keep constant
一即係你人哋攞呢樣咯，即係今日
即係好似我就話，因為你 collective 嘅 action 係啦，就會影響到呢個啦。因為你當佢諗係 GDP 嘅時候，就係講緊我哋全世界包含晒，加埋晒一齊啊嘛。所以呢個咪會影響到個 interest rate。我哋嘅 collective action 就會影響到個 interest rate。未得，係啊，我哋 individual 嘅 consumption 係諗我哋做嘅事。第一件事話俾你聽，我哋係冇錯。啱就講到你啱嘅，其實都先啱。即係我都聽你嘅。
之後用嚟
你個 equity 嗱，首先一個好重要嘅 equity 你個到底個市場上面嘅所謂嘅 interest rate 係乜？
市場上嘅 interest rate 就係
我講咗咪做過假錢
FOC、MC 佢哋點樣睇？
咁你點解 FOC 呢個嘅？
佢點樣睇個 market 我哋就
假設個 will 即係點解個上面講，即係如果真係要熟佢 market 去 determine 嘅嘢出嘅咧，係應該用呢個方法。其實即係你講嘅嗰個其實有少少係政府出嘅個 monetary policy 去影響個市場，能夠達到嘅一個水平。因為政府有佢自己嘅一個考量就係譬如話佢要控制飛，咁佢乜住控制飛嘅時候，佢咪要透過呢個方法去處理。呢個 beta 就係佢哋心目中我想達到嘅 beta， 唔係應該係話佢哋係會覺得就係話市場嘅 inflation 太高，咁我就要諗辦法將佢壓，因為嗱我哋呢度係真係冇考慮過 inflation 嘅，我哋呢度我知道個 price 呢個 good one 係一 price of 呢個 C2 其實就 1%， 但係我哋其實即係冇呢度，而且呢度係冇 inflation 嘅一樣嘢，冇 inflation 嘅一樣嘢，即係我哋冇一個 price 冇一個 client money 喺度，我哋冇講個 money 喺度，我哋只係講緊從一個 consumer 嘅角度點樣樣去做一個 intertemporal choice，OK， 咁所以其實而我哋呢個 intertemporal 嘅 choice 就會影響到我哋呢個市場入邊嘅嗰個 interest rate， 呢個 interest rate 亦都係導致到我哋之後點樣去 price 佢哋 asset 㗎嘛，所以點解佢呢個係重要嘅，重要嘅 sense 係話佢係攞呢個係一個開始，但係佢下一個 equation 係咩？下一個 equation 就係嗰個我諗住你哋已經識到你啦嘛，但係你一定呢一個啊嘛，呢個就係呢個就係你所有其他嘅 asset 你都可以用呢一個咁嘅時間去參加，即係你呢度可以呢個係 risk score 啊 ，risk asset 要定嘅嘢，咁你可以用我嘅 return 其實咁咪 return 就通過呢一嚿嘢咧計佢係 expectation， 可以計得出個 price， 因為呢個係 price today 啊嘛，咪1蚊 today 就等於1 plus half tomorrow， 係咪啊？咁佢呢個嘢令到你可以通過呢個 expectation 加埋一個 interest rate 就等於你即係today 呢一個 asset 嘅價錢。呢個係最基本嘅我有幾萬年前學過我唔記得咗你哋。其實有得計嘅，即係你係要幫我揸住個杯啊，佢哋通常唔係計嘅 asset price 係estimate 嘅，即係攞住實際嘅 data 去 estimate 呢一嚿嘅 estimate 之後再攞去放落去其他嘅 asset 度嘅 price。如果呢嚿嘢係計咗出嚟，即係以前呢嚿嘢計咗出嚟，你將佢抌翻入呢度，整個試翻嚟今日而家市場仲賣緊3年。其實呢個咧，其實你冇辦法可以真係計嘅。通常咧，即係譬如可能其實佢係攞住呢啲啱嘅，即係3年嗰啲債券或者唔同嘅 asset， 佢哋將呢一嚿嘢去翻做，跟住將呢一嚿嘢係啦，同埋再去嘅時候，可能有其他嘅 asset 嘅時候，咁佢就可以揸住呢嚿嘢去幫佢。呢個係大標年大個嚟做咯，所以佢哋都會有又唔可以俾得上堂。OK。
I guess we should continue. So I guess some of you asked me to the break, it worth talk a little bit. Some of you actually asked, okay, in undergrad you actually learned this, or in basic finance class, right? Is interest rate is determined by how people think about the future, right? That is what you learn, right? And what I told you is here is slightly different, right? If you rewrite this equation, right? Interest rate, right, will be 1 over beta minus 1, right? So this is how you explain the fluctuation of investment return, right? If you believe this is a model, you would think, okay, interest rate go up and down is because of people patience up and down, which is a little bit maybe okay. You think about, oh, okay, interest rate is high because people think about the future is going to end, beta is very small, also fine, right? But this is not a good model, I would say, right? Because not the model we have now is, instead of this is, we have this plus this guy, right? So that means that not just the patience, but also growth of consumption, right? And that means that consumption matter. As I said, this is what we call the consumption-based finance. It's trying to give you, to link the general economy or the macro to the model, right? Because consumption today, tomorrow is how people can spend, is the income, right? It's how much income they can make today or tomorrow, right? It's a GDP, total growth, all those kind of things together determine this, right? Is economy doing bad or well, they affect interest rate, right? That's why you look at this news every day, the US stock market adjusts according to the economic indicator they release, right? We talk about the non-farm, I think today, right? The non-farm occupation, unemployment rate, or all those things affect. Why? Got this, right? Those indicators, unemployment rate, all this affect, or inflation, all these things affecting this. And this feed back to the return, right? Remember why we care about R. R is the central thing of the finance, right? Is the investment return. We want to explain return, right? Return is price, right? Change in price is return. We want to explain return because we want to explain price, right? So, and some of you ask how we can apply this directly. And I want to ask why you don't ask this question when you learn this one. But the short answer is I try to collect the assets, return the financial market to the macro economy, or individual micro, the macro. And later, after turn this slide, we will give you the consumption-based capital asset pricing model. They call C cap M. Okay? You will see. Okay? And look at if your utility is not log, it's linear. U of C is C, then you don't have this guy. Okay? If you think people utility is not diminishing, then go back to the classical case. Okay? But as we know, I mean, I would say, right, our utility is diminishing, right? If you give me 1 million, I will be much more happier than you give 1 million to Bill Gates, right? So if that's the case, then this is the model. But we'll give you the model, okay? Now, as I said, I promise I will give you the consumption-based pricing equation. So we'll try to do all the derivation here. there will be some math, okay? But the math is just try to explain the intuition behind. If you learn asset pricing in the second year onward, I think second year, then I think they will give the same something similar there. Okay? But the first thing is we call the stochastic discount factor. Okay, is how you discount the future plus also the marginal utility. Okay, so this is very important thing, and if you learn math, they call the pricing kernel. Turn out to be this is very important in terms of pricing, but we are not in the asset pricing class. If you learn it, then it will be actually there's a lot huge of math behind to explain all this kind of stuff. But let's call this stochastic discount factor, and that's it. We're not going to very deep on this one. So how do we go forward from here? Okay, and what we do is we make it one step further. Is we are looking at the consumption are fixed at a level called E1 and E2. Okay, which we assume this can come from some macroeconomy, right? They call E1, E2, some model there. Okay, and because uncertainty, right? So the changes is today and tomorrow, right? With uncertainty, we have an E sign, right? Expected utility, right? So expected utility, right? The same as what we learned why we call expected utility approach, okay? And we talk about investment, okay? So what we are doing now is we want, sorry, there should be P, Taiwan here, there's P1 here, doesn't matter. So we want to have a investment, right? So far we don't have about asset pricing, we don't have about give the price, okay? Now we want to give the price directly. How to do that is the following, okay? So consider an investment, okay? If the investment is supposed to think you can buy an investment at price P1, okay? This is something I want to explain, what's P1. But given this price, okay, and there's a payoff, uncertain with X2. X2 can be high or low. There's a random variable there. I hope you know what's random variable. Just some number like this, right? Can be higher or lower, this random variable, right? And if you invest Y, right, this is the cost of investment, then you consume less in the first period. Then in the second period, you get the investment return, right? So the question is how much you should invest. Okay? Of course, the investment depends on the investment price, but that will be the key. So, but first we talk about optimal investment. Is that clear what we're doing? Okay? The previous question is looking at we just save, right? Now we have a little bit more difficult is looking at how much investment I should invest. Okay, so the problem is choosing the investment, okay, such that this will satisfy. Okay, so given the price, okay. So although this question looks crazy, probably you would think, okay, how do you solve this? If you know math, it's simple Lagrangian. But we're not going to do the math. We just give you the intuition. The model is, you can see, very complicated. I'm not going to go to the derivation. Instead, I go to the solution directly. Okay, this is a solution. If you learn math, that is very simple, just because this is just a single variable calculus. But let's don't do math, let's do intuition. Okay? Ask ourselves, if I do one more unit of investment of Y, what's the cost of doing it? I do one more unit of Y, how much I need to pay? P1 more, right? And that means I have to reduce my consumption by C1. Y1, Y, by P1, right? P is the price, right? I invest one more unit, I go Y, go by 1, right? I need to pay P1 more, right? And P1 would means consumption will reduce by P1, right? By the budget, okay? And how much loss of utility, right? It's P1 times the marginal utility. Okay, this is the cost of doing it, right? Is that clear? And what is the benefit of doing the investment? The investment will give a return of x2, right? Right? And this gives you this utility, right? Because 1 unit of investment gives you x2 unit of return, right? And this return, how much give utility is U prime of C2. Okay? Now, in equilibrium, optimal, they will be equal, right? Because in equilibrium, you should be thinking about today, tomorrow, the same, right? Is that okay? And is that okay for this equation? But at the end of the day, this is the equation we get. Price is, you just put this on the other side, right? Price equal to this M times future payoff. Okay? So what is this? What am I doing? If you learn the first class of finance, one of the model you learn is what? DCF. Anyone remember DCF? Discount cash flow, right? What you do is tomorrow cash, you discount by your patience, beta, right? Beta times that and so on and so forth, right? So here, what's different from the DCF here? Is this guy. Of course, also uncertainty, right? Because this is future cash flow. If everything is certain, this is, you know what the cash is there. You just discount it by your patience, right? And usually the beta you use is 1 plus R, right? That's how you should usually use, right? Because you assume many things, make it work, right? But here I tell you that if you more careful, you shouldn't just discount cash flow in this way. You should use the stochastic discount factor. It depends on your consumption. Okay, so today's price, this is what we call the central pricing equation. Today's price, okay, is tomorrow uncertain return, discount by this stochastic discount factor. So this is the advanced version of DCF, you can say. Okay. So don't worry, we will give more, but in general, this equation, we start from this one. Okay, so you can see a lot of math, but at the end, it's very simple, right? The only complication is you need to take into account of how people consumption changes, right? That's very important. Otherwise, everything will become very mechanical, right? What you learn undergrad is the same, right? You just discount the future by interest discount factor, right? Right? This is DCF, right? Okay, is that clear what we're doing? Okay. Is that okay? Is that okay? No? Okay. So, if, put it this way, today is 1, today's T is 1, right? T, let's see if I can use this one. So let me explain. So this is T is 1, T is 2, okay? And suppose there's an asset that costs you P1, okay? And gives you return X2, okay? Right? And your discount factor is beta. Usually you learn undergrad 1 is R, right? If you use the discount cash flow model, the market is perfect. How should this asset value, right, will be x2 minus 1 minus R, right? This is the present value, right? And this present value should be your price, right? This is what you learn. Am I right? I mean, I hope you learned this, right? Otherwise, I can't teach anything. Is that okay? Right? The first thing we add is one thing first is we add expected value. Why? Because x2 in the model is certain, right? We learned DCF, but it's uncertain. You expect value. But x2 can be 3, can be 4, can be 5. You assign probability just like that, right? Suppose x2 can be half of time is 3, half of time is 1. Then you just do the expectation, right? This is okay. Is it okay? Right? This you learn in the just very simple, right? Now, the thing that I want to say is, under the model, we tell you that this is not the whole story, and this should not be the whole story. It should depend people's decision. The utility is not linear, right? Depend on how much he consumed right now, right? If you are consuming a lot, give you $1 more doesn't mean a lot, right? You can imagine that there's situation because uncertainty, right? In the world where the economy is good, give you $1 doesn't worth as much as when the economy is bad, they give $1, right? That's what you learn in the investment, where the safe assets would cost more, right? So that comes out from here, right? And that's why you cannot this. You have to multiply by, say, this is to be this, right? Beta x2, but not enough. We instead of beta, we use M, right? M have to be related to the consumption marginal rate substitution. That is the new thing I adding here. Yes, question.
From the previous formula to this given derivation, why would it be expectation
Oh, why expectation? Because the consumption also depend on uncertainty. You don't know the consumption tomorrow. Oh, because U prime is certain, but the C2 is not certain. C2 is depend on the investment return as well. You consume everything. Oh, that you can take it out, doesn't matter. Same. Expectation constant is the same thing. Is that clear? So nothing new but DCF, right? The discount cash flow, first, take into account with uncertainty. Second, take into account with diminishing marginal utility. Then give you this equation, right? And later you will see this will give us the pricing equation. Okay? So this is what we call the fundamental pricing equation, right? But you learn it already, right? It's just discount cash flow, but an advanced version. Is that okay? I mean, if okay, I can explain more, but is there any question? I don't want to rush through because I can rush through the derivation, but I don't want to rush through the intuition. Is that okay? So this pricing equation we can learn a lot from that. Okay. So if we rewrite, okay, future return, future payoff over the price is the return, right? Rate of return, this definition, right? And if you divide PT on both sides, this is what we have. 1 equal to RT plus 1, M plus 1, okay? So that's basically the pricing equation, discount cash flow in terms of return. Okay, this one is just the same guy, same thing here. You just divide both sides by PT, this has become 1, this becomes RT plus 1. Is that clear? Nothing new here. But this is the pricing equation in terms of return. Is that okay? Because this is the fundamental, so that's why we need to talk about that. So let's see the first thing here. The first thing here is some of you would ask, okay, how can we measure now we have the new thing called stochastic discount factor. How can we measure that? Okay, we can measure it. It's very simple. If you look at the risk-free market, okay, look at the US Treasury bond, Treasury bill, right? That one is risk-free, supposed to be. If the risk-free, the R can be taken out, right? Expectation size, no meaning, right? That's we learned undergrad, right? Expectation of a constant, you can take it out. Okay? That means that the risk-free return and the discount factor is inversely related. So I can track what is the stochastic discount factor. Okay? That means that depending on how you use, discount factor tells you the risk-free rate, if you can predict that. Or reversely, the risk-free rate can predict how people discount the future. Okay? If you think the market efficient, doesn't really matter, you look at it. Right? So this is the first thing that very nice from this model. Okay? But of course, there's nothing different from what we have, right? But this thing just apply to risk-free, right? When the risky, this equation doesn't hold anymore. I hope this tells you something you didn't learn in the past. Okay? And the second thing I try to tell you is if we take log utility, which we assume, then the risk-free rate can be decomposed in two parts. Okay? One is how people patience, which usually we assume unchanged in a short period of time. Maybe demography change will change the beta because people dying don't care about future. People are young, care about a lot about future, but if you talk about today or tomorrow or 1 week, doesn't change beta, right? So what the risk-free rate changes reflecting is consumption growth, right? And you can look at the GDP, right? And that's how the risk-free rate is being understood. Okay? Of course, this is the simple model, very simple model to explain the bond price movement, right? Is that clear? So if you undergrad, you don't have this guy, this is what you learn. But now you learn more fundamental of the consumption behavior. People utility is marginality is diminishing, so this is what you learn. So that means what? Macro matters for risk-free rate. Okay? Is that clear? And if you have the power utility the same, but just raised to the gamma there, okay? Depend on how concave the utility you are, right? Okay? But I'm not the same result. I'm not going to do there, okay? Now, we are going to give you an advanced version of DCF, okay? Discount cash flow, okay? So look at the second line, price today, tomorrow uncertain return, discount by the stochastic factor. This is the second row, okay? And the first line is what? The first line, maybe I should use the beam. Yeah. So this covariance, okay? And is same as expectation of sum minus, so expected product minus product of expectation. This is formula that you learned undergrad, but I'm pretty sure that no one will remember Anyway, take this, okay? And you replace this guy here. This guy is equal to the covariance plus the product, right? This guy is this plus this guy. Is that okay? So this is the formula. Is that clear? Don't worry about if you forget the derivation, because at the end of the day, I want to use this formula. Okay? Because we saw the risk-free rate is 1 over the discount factor. So this guy is just RF. Okay? So what we have is this fundamental formula of DCF, advanced version. Okay? What is the price today? Is look at the expected future return, discount by the risk-free rate. This is the standard DCF, right? Nothing new there, right? What's new is this guy, okay? There's something new that you should pay attention is you adjust by covariance of your discount factor and your asset return, okay? This is called the risk, it's called risk adjustment. Okay, we'll talk about this in the next slide, but this is very important because this will tell us a lot of story. But this is the main thing. Okay, but don't be scared by the math. But it simply means that if your assets is risky, you would discount your expected future cash flow, standard. But also you would care about how this asset return related to the economy, right? Because remember the M is really the consumption ratio, right? Marginal substitution. So you can think in your head is M is just patience and economy growth, right? Say is what it means is the asset price not just depend on how well the assets giving the return, but how well is the covariance of this related to the economy. Okay? So do note that the risk adjustment is not you learn in the investment class. Investment class will tell you it depends on the variance of this guy, right? It's not just about the variance or covariance of this, right? But it's the covariance with the whole economy, right? So it's not, you cannot look at things in isolation, right? The classical thing you do is not perfect. Okay? So let's give you more detail on this one. Okay. So this is a risk adjustment factor. We call what is the stochastic discount factor is the patience beta, right? Multiplied by the marginal rate of substitution, right? Or the marginal utility ratio, okay? If you write that, okay, just plug that in. It depends on this funny thing, okay? And important is interpretation, okay? Today consumption we know because this is today GDP, okay? So this part is no uncertainty. We can calculate that part. This part is a constant you can think because nothing changes, right? We look about the future, right? So only the matter is beta is also fixed as assumption, right? So usually we look at it is how future return related to future GDP, right? It's looking at how the risk adjustment depend on the future return of the bond or stock you're looking at compared to how it covariance with the consumption, right? What it means is, funny thing is, if this covariance is 0, say, suppose, right? Suppose the return of the financial instrument is unrelated to the economy, okay, this thing is 0, right? And right. And next is what happens if C and T are positive related, right? Right? Say, which is something like economy is good, the stock pay more. You can imagine that what happened is the covariance, okay? Look at, it's not about the C and X, it's about U prime, okay? Do remind yourself that your marginal utility is decreasing, it's getting smaller and smaller when your consumption goes up, right? So you just have to flip your head, right? So if your investment goes up with the economy, right, this will be negative, right? So this risk adjustment negative means that, okay, to be lower, the adjustment, right? If it's negative consumption, you need to pay higher. Okay? Let me explain, easier to explain this one first, maybe easier to explain why this is true. So consider an investment which gives you return when economy is bad, right? When economy is bad, you would care more about $1 at that time. So you would need to pay more for that. So that's why this adjustment higher. Is that clear? Is that clear? So that's why the insurance company charge premium, because they give you money when you're bad luck. Okay, let me explain a little bit further, because I'm pretty sure many of you can't see clearly. So the first thing in our head is a little bit tricky, because marginal utility is actually reduced when you have high consumption, okay? So that's why for investment that is positive with consumption, right? That means that actually it's negative, right? That means that if you try to buy an investment that is go up when economy go up, go down, actually cheaper. Adjustment is reducing, right? If they're unrelated, they're 0. So what it means is the classical thing we just discussed, variance covariance approach, is wrong, right? It's not about variance of the portfolio, right? It's variance of, it's the covariance of this guy. So that is the classical way. That's why it's, I mean, we still use it, but now people use this more general framework, right? Because this thing is not entirely correct, right? If this is right, why we want to buy safe haven, safe assets, why people buy Bitcoin, why people buy antique, those kind of stuff, can't be explained, right? Is that okay? So I still have 4 minutes. I think it's enough to finish this one. It's give you the beta, as I promised, I give you the beta pricing equation, the CAPM model, but with consumption. So don't worry, it's the same formula, right? I don't know whether you still remember this formula, but not, don't worry. It's simply this formula, you divide it by P, right? Then might give you this one, right? This one, right? It's just saying that the return time discount factor should be 1, okay? Well, but of course, you can think this is, it simply means no arbitrage, right? Now again, we are exploring our definition of covariance, which you learned undergrad. It's just covariance is expectation of product and product expectation, okay? And if we write that, this guy, right, with this here, it's just covariance plus the product, okay? And again, we are being lazy here, this guy, okay? This M is the risk-free rate. We can use this guy, replace risk-free rate. Okay. 1 over risk-free rate. You multiply risk-free both sides. Okay. And subtract, give you this formula. So this risk premium is equal to negative of this guy times covariance. Maybe I write the math in case you want to know. So this guy is 1 over RF, okay? And you multiply both sides by RF, right? All right, same. Maybe I just write down here, since just copy here. So this is the formula. Okay. I just skip one step, because this guy is just 1 over risk-free, right? You multiply RF on both sides. And just move it to this side, this to that side, this gives you the formula. Okay? I mean, of course, I'm not asking you to do derivation, but just tell you that how this can be arrived there. I'm not just give you the formula and that's it, right? But I don't think you would care about the derivation, just being a little bit lazy here, but I guess it'll be fine. So you can see the risk premium depend on this formula, because M can be rewrite as C over this guy, okay? And just rewrite that, okay? And it explains the same thing as I said, how the risk premium is being determined there, right? And you're willing to pay more when discount factor is large, or risky assets, or instruments with negative premium. But this is not different from what we have before, right? The intuition, okay? But just in terms of return. Okay. So bear with me. This is the last 2 slides that we have a dinner. Okay. So this is the formula we have. Okay. And what I'm going to do is to write the consumption-based cap M. How I do that? Okay. Remember this guy, risk-free, can be rewrite as discount factor. So I just do this again. Okay. And the next, I do a very special trick here, is to decompose it into 2 fractions. The same, I can cancel out. Okay. Why I do that is because this is just related to variance over expectation of the discount factor. It's macro part, unrelated to the asset itself, right? It's under, and this part is the beta, is assets related, right? How assets related to the whole market, right? And that is the beta pricing equation, right? The return of your assets is the risk-free plus beta times the quantity of that, right? And the first part depends on assets characteristic, and the second part is depend on the macroeconomy, right? The economy is bad or good will determine the price of risk, right? This is looking at how risky is the asset, right? Because how risky depend on covariance over variance, the same as the beta that you learn, right? right? And this is different from different assets, and this is the same for all assets, right? And this beta equation, of course, different from the thing you learn in the investment class, right? Of course, you ask, okay, why I go all the way to this? You need to remember, oh no, of course, just to try to show you that, okay, in this model, this nothing with the macro, right? And here I tell you that, okay, your risk premium, the risk-free, the risk premium part, right? The risk premium, or risk adjustment, as you say, or risk premium, right? Depend on what? Or the excess return, depend on what? Depend on the price of risk, which is the macroeconomy, right? The variance over the expectation, right? This guy. Okay. And this guy is depend on how the stock or the investment instrument related to the economy, right? This is economy related to economy, right? So that's why in recent literature, some people would call this macro finance approach. Is saying macro is finance, finance is macro. So basically, there's no difference between the two. And the reason is this guy, right? If you learn this, there's no macro. And this explains why macro is important and why you see economy indicator announcement would change so much the stock market, right? Because that change how we expect things in the future. Okay? I guess I should stop. After the dinner, we'll talk about game theory. I stay around to answer any question you may have. See you after dinner.